In this video, we'll talk more about angle pairs. If you haven't already, make sure you check out Angle Pairs Part 1, as a lot of that will be essential to understanding the concepts that we discuss in this video. So in this video, we'll mostly be concerning ourselves with angle pairs that are created from parallel lines and a transversal. And, well, if we think about parallel lines, those are lines that lie in the same plane that never touch, or we could think of it as they are always equidistant from one another. So these two lines, I think we could agree, are parallel or nearly parallel. Let's go ahead and assume that they are parallel, just for the sake of the sake in this video. And then this line that crosses them was what we call a transversal. And basically it's just a line that crosses two or more parallel lines. It's a fancy name for a line that just crosses them. And what happens here is that we have a bunch of angles that are created. So like, for example, if I look at this angle and this angle here that I've highlighted in green, these are what we call corresponding angles. And it would kind of make sense that, okay, say this line here hits this line at, say, 30 degrees. It would also make sense that if this other line is parallel to it, this should also be a 30-degree angle. So corresponding angles are always congruent if we're talking about them in this sense. Now, not to be confused with when we're talking about corresponding angles of two congruent polygons, but the idea is I've just taken this top piece and I've just shifted it down to make this other one, or translated, if we would prefer that verbiage. But anyway, the takeaway is that those two angles are always going to be congruent. And I could say the same thing of this angle and this angle right here. I'll mark them with a tick just so they stand out a little bit differently. Those would also be corresponding angles, so long as they're in the same position. So top left is congruent to top left, top right congruent to top right, so on and so forth. Now, we know that if we're looking at these two angles, those are congruent because they're vertical angles. We've talked about that one. Now, we can kind of extend this thought even if we look at these two angles, and I'll mark them in a different color. We'll talk about them in yellow. These ones that are marked in yellow are what we call alternate interior angles. And again, these angles end up being congruent. And the idea is, well, we could use a combination of vertical and corresponding angles to get there, or we can take the shortcut. And these would be what we call alternate interior angles. They're on the inside of the parallel lines. Now that also draws the question, well, what about, say, these two angles? And again, these two angles we can say are congruent, and those are what we call alternate exterior angles. And the idea is I can make a lot of deductions about angles created from these transversals and parallel lines. And we'll talk about an example to kind of have it all make sense. So you might be asking, okay, well, this is great. Why do we care about these angle pairs? Why with all the vocabulary? Well, the idea is, say I have this example here where I know these two lines are parallel. Usually textbooks will mark them with a little arrow or maybe two arrows to denote that. And we have a transversal that's crossing them. And the only angle I know is this one that's 50 degrees. Well, it turns out I can actually figure out all the rest of the angles here. I know that because of vertical angles, this one also has to be 50 degrees. I can deduce that this angle in the top left must be the same as this because it's a corresponding angle. So those are the same. It's also 50 degrees. And then I could make a deduction, and I've got two ways to go about this one. I could go straight through and say, okay, well, there's alternate exterior angles, or I can do corresponding off of a vertical angle. Either way, all four of those angles are congruent. And likewise, I can make a deduction about the rest as well. I know that a line has set up to 180 degrees. Therefore, this little guy, or not the little guy, the big angle, I guess I should say, would be 130 degrees. Because if I take 50 away from 180, 130 is what's left. Likewise, I can say, okay, well, if that's 130, the other one across from it must be 130 because of vertical angles. And I can also say this one is 130 degrees because of corresponding angles. Or I could even say alternate interior angles with this other one here. And likewise, the last one must be congruent as well. Now, there's a lot of ways you can use these things to your advantage, and you don't necessarily have to use one over the other, but just knowing that these angles are congruent in certain cases and being very careful when you can and can't use them is quite useful in a lot of situations. It comes up a lot more than you would think. But anyway, that's more angle pairs, and these ones are more concerning with strictly parallel lines cut by a transversal.